Rational expressions. Rational expressions can be described as a polynomial fraction or as a ratio of two polynomials. Working with rational expressions is similar to working with fractions. Rational expressions can be simplified by factoring each polynomial and canceling out terms. So a rational expression means that it's a polynomial in the top divided by a polynomial in the denominator. To simplify, we want to factor all the terms, factor the denominator and the numerator, and then cancel any like terms that we may have. So I'm going to do these problems on a separate sheet of paper. So here's example 37. So the first thing we want to do is to factor the numerator and the denominator. So for this example, x minus 2 is already factored. X squared minus 4, as you recall from the previous day, can be factored as x minus 2 times x plus 2. And now here, if you notice, we have x minus 2 in the numerator and x minus 2 in the denominator. So that terms will become a 1, or we say they cancel, leaving us with 1 divided by x plus 2. And so this would be our simplified answer. Example 38. So again, first, we want to factor out any terms from the numerator. So here we have a 5 and a 25. So the greatest common factor would be 5. So if I factor out a 5, I'm left with x. And if I factor out a 5 here, I'm left with 5. So 5 times x is 5x. 5 times negative 5 is negative 25. Divided by x squared minus 25 can be factored as x minus 5 times x plus 5. And again, you can see that x minus 5 is common to x minus 5 in the denominator. So we're left with 5 divided by x plus 5. Example 39. We're going to multiply rational functions. In order to multiply, we first want to rewrite these rational expressions in simplified form. So x plus 2 is already factored. X squared minus 9, we can write it as x minus 3 times x plus 3 times, we have x minus 3 here. X squared minus 4 can be written as x minus 2 times x plus 2. So if we multiply across, then we get x plus 2 times x minus 3 in the numerator, so this times this. And the denominator, we get x minus 3 times x plus 3 times x minus 2 times x plus 2. We want to cancel any like terms, so we can cancel out x plus 2 with x plus 2 and x minus 3 with x minus 3. And so we're left with 1 divided by x plus 3 times x minus 2. Example 40, division. So here we have x squared minus 5x minus 6. That can be factored as x times x is x squared. Then we need the 6 to be a negative. So one would be negative, the other would be positive. The 5 is negative, so the bigger number will be negative. We can check our work. X times x is x squared. X times 1 is 1x minus 6x gives us negative 5x. Negative 6 times 1 gives me negative 6. Down here we have x times x. For x squared, then we need a 3 times 1 with a negative 2 is negative, so the bigger number has to be negative. Divided by, and we can factor here. This would be 2x times x. We need to have an 11, so I can use 6 and 1. So 2x times negative 6 is negative 12. Plus 1x gives me negative 11x. Negative 6 times 1 is negative 6. x minus 3 times x plus 3 for the denominator. In division, well, here we can cancel out, for example, x plus 1 and x plus 1. And so now I'm left with x minus 6 divided by x minus 3 divided by 2x plus 1 times x minus 6 divided by x minus 3 times x plus 3. I can rewrite this as x minus 6 divided by x minus 3, change the division sign to multiplication, and I can do that if I take the reciprocal. So I get x minus 3 times x plus 3 divided by 2x plus 1 times x minus 6. Okay, multiply these out. So this times this will give me x minus 6 times x minus 3 times x plus 3. And then the denominator is x minus 3 times 2x plus 1 times x minus 6. Cancel out any like terms. So we have x minus 3, x minus 3, x minus 6, x minus 6. So we're left with x plus 3 divided by 2x plus 1. Example 41, we want to add the fractions. So first we need to factor any terms that we can. So I get x minus 1 divided by x minus 2 times x plus 2, or x squared minus 4, plus, here we're going to have, we need the 6 to be positive, so that's going to be a minus 3 and a minus 2. In order to add these fractions, we need to have a common denominator. So our common denominator is going to be the factors that we have in the denominator. So I'm going to use x minus 2, x plus 2, x minus 3, and then x minus 2, I already have it, so I don't need to use it again. So you want to ask yourself, from this denominator, what is it missing so that it gives us this common denominator? And so we're missing here an x minus 3. So I have to multiply x minus 3 on the top and on the bottom. So I'm left with x minus 1 times x minus 3. And on this side, the term that is missing is the x plus 2. So I need to multiply the top and the bottom by x plus 2, since that becomes a 1. So I get x plus 2 times x plus 2. Let's multiply the numerators. So x times x is x squared minus 3x minus x plus 3, plus x times x is x squared plus 2x plus 2x plus 4. And this is all divided by x minus 2, x plus 2, x minus 3. Gather our like terms. We have x squared and x squared is 2x squared. Negative 3x and negative x is negative 4x. Plus 4x gives me 0. And 3 plus 4 is 7. And this would be our answer. For subtraction, similar to the addition, you want to factor all the terms that we can. So for x squared plus 5x plus 6, I get x plus 3, x plus 2, minus here I have 12, so I can use 4 times 3. I need to have a negative, so that would be in the front of the biggest number. So my common denominator is going to be x plus 3, x plus 2, x minus 4, and x plus 3 is already being used. So in this denominator, we're missing the x minus 4. So we can multiply x minus 4 on the numerator and denominator. So we end up with 2x minus 1 times x minus 4. And on this side, we're missing the x plus 2. So we multiply the numerator and denominator by x plus 2. So we end up with 7 times x plus 2. Multiply this out. 2x times x is 2x squared minus 8x minus x plus 4, all divided by our denominator. And here we get 7x plus 14 divided by our denominator. Now that they have the same denominator, we can combine like terms. So I'm going to have 2x squared minus 8x minus x plus 4 minus, and I'm going to use parentheses here. So it's minus the whole thing, so minus 7x plus 14, all divided by the denominator. So we end up with 2x squared minus 8x, and x is negative 9x plus 4, distribute the negative. And the denominator stays the same. So I end up with 2x squared, negative 9 and negative 7 is negative 16x minus 10 divided by all of this. So that was adding and subtracting rational expressions, multiplying and dividing. So now we can try a few examples that are similar to what you might see on the exam. So we're defining x divided by x plus 2 plus 3x minus 12 divided by x plus 2 times x minus 4. So the first thing is to simplify. So for 3x minus 12, they have a 3 in common, so I can take out 3x, a 3. That leaves me with an x, and the 12, if I divide by 3, will leave me with a 4. By doing this, then we can see if there's any like terms that we can cancel, and there is, x minus 4. So now I can rewrite this as x divided by x plus 2 plus 3 divided by x plus 2. And if you notice, now they have the same denominator. So I just have to add across. X plus 3 is, I'm going to have x plus 3 divided by x plus 2. So that answer is letter B. Letter C, we have x divided by 2y plus 4x divided by y minus x divided by y equals to something. So we need a common denominator. And I'm going to go ahead and use the 2y. So here, notice that we already have a 2y. So we just write down our x. But for this y, we're missing a 2. So I'm going to multiply this by 2 and this by 2. So I get 8x. And then this one is missing a 2 as well. So I get 2y. So now we can combine like terms. So I get 2x on this one. So we have x plus 8x is 9x minus 2x is 7x divided by 2y. Letter C. Here we have We can rewrite this problem as v divided by 3d divided by 3d divided by 3v. So now I can change this to multiplication if I use the reciprocal. Since I'm multiplying, then I can keep simplifying. 3 divided by 3 is 1. So I'm left with v divided by d, multiply across. V times v is v squared divided by 3d squared. So this answer choice is not in the booklet. Let me show you. Number 3 on the booklet has different variables. Okay, so I have m and s, but we're working with v and d. So our answer here was v squared times 3d squared. And the next one we have, if x is greater than 2, then this times this is going to be equal to something. So again, the first thing you want to do is factor if you're able to. So I get x times x is x squared. And then the 6 is positive, so both signs have to be the same. So minus 3 and minus 2 divided by x plus 1 times x plus 1 divided by x minus 2. So now that we have simplified, we can see if there's anything that will cancel. And if not, we can write it out. So x minus 3 times x minus 2 times x plus 1 divided by x plus 1 times x minus 2. So the x minus 2 will become a 1, so they cancel. And I'm left with x minus 3, which is letter B. So the next video will be on complex fractions.